Hello guys. So in previous lecture we have known about there are so many network theorems. Okay. So for today's lecture our topic is superposition theorem. Okay. So let's start this. Superposition theorem, the voltage across or current through an element in a linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. Okay, we'll understand it with another one explanation. So that's it. The response of a network, the response can be voltage or can be current with several independent sources. Okay, uh, so the circuit has more than one independent sources can be obtained. It can be obtained as the sum of responses to sources, as the sum of the responses to sources. So taken one at a time as a consequence of circuit linearity. Okay, so at a time we'll assume only one sources when there is more than one sources present in the circuit. By in removing sources other than one, so we'll remove one. We'll just keep one source, one independent source, and we'll remove other sources. Okay, voltage sources will remove by making it short circuit, and current sources by open circuit. Okay, so as you can see here, that is the first one at left side one is the a voltage sources will make it short circuit, and on the right side one there is one current source will make it open circuit. Okay, for superposition theorem. So let's understand what is independent sources and dependent sources. Independent sources, it is an active element that provides a specified voltage or current that is completely independent of other circuit variables. And dependent sources, it is an active element in which the source quantity is controlled by another voltage or current in the circuit. So in normally you can just say the independent sources, it does not depend on any other element, the source any other element or source in present in the circuit, but the dependent sources says the source quantity or the source output depend or controlled by other voltage or current source in the circuit. For the superposition theorem, we have to these two are the one of them. We have to keep in mind that it dependent sources we have to left as there. Okay, we don't need to remove it from the circuit, dependent sources. And for independent sources we'll assume one by one, we'll keep one by one, and we'll remove others. And this theorem is not valid in case of non-linear circuit. Okay, this theorem is valid for linear circuit only. So we'll understand this within one, we'll understand this superposition theorem with one simple problem. So by using superposition theorem we have to calculate the voltage across the 4 ohm volt. So at first we will consider the 6 voltage source, 6 volt voltage source. Okay, 6 volt voltage sources we will first consider. So we'll remove the other 3 ampere source. Okay, so this is the circuit. It will be after removing the 3 ampere source. So we'll remove 3 ampere source by it's a current source, so we'll open circuit it. So, and we'll assume I1 current through this loop. Okay, through the loop, because other part is open circuit, so current will not flow through that part, through the right side part. So we are assuming I current is flowing through following through in this direction. So by applying KVL, Kirchhoff's voltage law, we can calculate the I1. Okay, we can calculate the I1. We can calculate the I1. So at first 6 volt it's coming, then I1 into 8 minus voltage drop. Okay, these are the voltage drop. So these are the resistance. There will be voltage drop in every resistance, across all the resistance. There will be voltage drop. So 6 volt, it will be our positive volt. Okay, 6 minus 8 into I1 minus 4 into I1 is equal to 0. That one we know from the KVL. Okay, voltage in a loop or circuit or in a mesh is the algebraic sum in a loop. Algebraic sum of voltage in a loop is 0. So from there we'll get 12 volt. I1 is equal to 2 or 0. So I1 is equal to 0.5 ampere. Okay, sorry. So the V1, we know V is equal to IR Ohm's law. So V1 is equal to I1 into 4. I1 is into 4 ohm. We are calculating V1 across 4 ohm resistor. Okay, so V1 is equal to I1 into 4. So it will come, we have calculated already I1 0.5. So V1 is equal to 0.5 into 4 is equal to 2 volt. Okay, so for the next phase of this uh, solution, we will consider the 3 ampere current. Okay, 3 here 3 ampere current source, and we'll remove the 6 volt voltage source by making it short circuit. So, and we'll assume current in 4 ohm branch is I2. Okay, we'll assume current in 4 ohm branch is I2, and the voltage across 4 ohm 4 ohm resistor is V2. So by applying current divider rule, because we know the total current 3 ampere that is flowing through this circuit. Okay, so we can apply the current divider rule, and we'll the current divided from the current divided rule we can get, look, current divided rule is total the current through that branch. This one we are calculating for I2. So I2 is equal to total current into other resistance by sum of two resistance, because here only two resistance is there. So we are assuming these two, say, parallel resistance. Okay, so I2 is equal to 3 into 8 by 8 plus 4. We can see from the circuit there is other resistance, that is 8 ohm, and the total resistance it will be 8 plus 4. So from there we'll get 2 ampere. So V2 is equal to, again we have to calculate V2. So V2 is equal to V is equal to IR, from the same Ohm's law formula, from the same Ohm's law, that is V is equal to IR. So V2 is equal to IT into I2 into R. Here it will be 4 ohm. So the total so the V2 will be 8 volt. Okay, so the total, the net voltage or the total voltage across the 4 ohm resistor is V is equal to V1 plus V2. We have calculated V1 in the first phase, that is 2 ohm, and now we have calculated here, that is V2 is equal to 8 ohm. So the voltage across 4 volt ampere, 4 volt resistor, or the V, or the value of V is equal to 10 volt. Okay, so that's it. If you have any doubts, you can comment in the comment box. I'm trying to explain it in details and in a very easy way. So bye bye.